Are we working on packet 1?
Packet 2.
Packet 2.
All right. These are a couple of review problems from our class on Friday. If you have not, if you weren't here on Friday or you didn't listen to the YouTube, you may be a little lost when you hear some of the things that I talk about. So make sure and go back and listen to the YouTube. You may catch on. Okay. One of the things that we decided here is when you have a radical, the radical is actually this little house looking thing. That's called a radical. And so I call this whole thing a radical or a square root or whatever. And then another thing that we found out on Friday is that if right here in the V tells us what root we're working with, okay? If there is none there, it's an invisible square root, which means an invisible 2. Now, the reason that they left that out is because the square root is used so many times that there's no reason to put it there. They only put a root inside this V when they're using a different one than a square root, okay? So this is one of the invisibles that is not a 1. It's an understood square root, okay? And what we talked about is in fractions, you know that way back in grade school, they said if you have a fraction that needs to be simplified, always simplify it, always, okay? And that's going to be the same way with our radical numbers, all right? If they can be simplified, you should simplify them. Now, there's 2 ways to simplify. You can put this in your calculator and get a decimal answer, and sometimes that's okay. But many, many, many times, including today, you're going to need the simplified radical, not a decimal. And so we found out that there were also 2 ways of simplifying. We found out that you could take this 108, look at your square root, cheat sheet, and see what perfect square will divide into this, and then you work on it and blah, blah, blah. It is a great way, and most math teachers teach that way, okay? And there's not a problem with it, and I think that's wonderful. I think here, as we are adults, and we haven't learned that way, and I'll tell you why I teach this, because this is easier for me. Okay, since you are adults, I say we teach you a stupid story that you can remember, and it works every single time. Okay, so what we talked about, just a quick overview, we talked about this being a house, and this, just like the house where I live, is the Bond's house. This is the 108's house. Okay, and in this house is parents and teenagers, okay? And the teenagers want to go out on Saturday night, and mom says, I understand that, but I want you to be careful. Times are different than when I went out. And so I want you to go out in groups. Now the root up here tells them how many need to be in a group, okay? And so that's kind of the overview of our story. Now we need to know how many teenagers and who they are. We need to find the teenagers. That's why I taught you how to do prime factorization, or the factor tree. So what we're going to do is work from here and do a factor tree. And that is in our other YouTube videos if you want to go back and see how to do a factor tree. What we do is find out any 2 numbers that will multiply together to give you 108, okay? And I did have a question from one that said, so do I do 10 and then do I do 8? No, it's the whole number. You need to find out what divides into this. That's why in your packet, you have the divisibility rules that help you decide what this will divide by. Now, you can do anything you want to, but if it's an even number, you can divide by 2, okay? So if I divide by 2, I'm going to get 54, okay? 2 times 54 will give me 108. Now we found out also that if you come up with a prime number means that it will only divide by itself and 1. It won't divide by anything else. So this is a prime. This is not. This is an even number, and that's the easiest way to chop these down. 2 times 27?
Yes.
27. And 2 is a prime. Make sure you circle these because some of these numbers get big and there's a lot of primes and they'll get lost in here. So continue to circle your primes. Now when we have 27, 27 is not an even number, so we're going to try 3. And we've got 3 times 9 is 27, and 9 will still divide by 3 and give you 3. So this gives us all of the prime factorization. When you look at the bottom of this, you're going to find out all the primes. Now, no matter how you started up here at the top, no matter what 2 factors you started with, you will end up with these prime factors. You will end up with 3 of these and 2 of these in any kind of order. But no matter how we start, we'll end up in the same place. Okay? Now, just to take a side trip real quick, if they want you to write 108 as power of primes, then you will say 2 times 2 times 3 times 3 times 3. Okay? 3 times 3 times 3 times 2 times 2. Here it is. And if they want a shorter way or more compact way, we say there's 2 squared times 3 was multiplied 3 times. So this would be the best answer for the product of primes. Okay, everybody? Now that's just a side trip. Let's go back to the house full of teenagers. And they want to go out on Saturday night. Mom is very understanding. And she says, sure, you can go out, but I only will let you go out if you have a group of 2. A group of 2. If you can't find a group of 2, you're going to have to stay home. Sorry, going to have to stay home. So here's the house. I didn't give us much room. Okay, here's the house. Now we're going to decide who can go out of the house and who can stay, who has to stay in. So she said groups of 2. So these 2 guys got together and they said, aha, we have a group. Okay, I mark those out so I don't get mixed up. Mark those out. Now when these 2 people go out of the house, they're no longer 2 people. It's 1 group. It's a 2 group. So this 2 group gets to go outside of the house. And then 3 goes, ha, 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 I found one. Okay. And so these 2 people go out of the house, but they could become a 3 group. And I'm going to have to cram it in here. Okay. So they get to go out of the house because it's a 3 group. Notice I did not write 2 3s. I only wrote 1 for the group. And then we look around the house and there's one that can't find a group. He stays inside. Anything, if you have multiple numbers in here, you're going to multiply. If you have multiple numbers out here, you're going to multiply. It's not 32. It's 3 times 2. And so the simplified radical of this is 6 square roots of 3. Are you following the stupid story? Kinda.
Yes and no.
Okay. Okay, we'll do some more.
So the ones that are grouped outside the house, those are always going to be multiplied.
Yes, if
And
they're.
And the whatever number is in the house is always going to stay the same.
Yes, but there could be a 5 in there. also, or another 3. Well, it wouldn't be another 3, but a 2 maybe. If there's a 2 and a 5 and a 3 in there, they're all going to be multiplied together to give you 30. Okay.
Okay.
If that's the case.
Okay.
Okay. So any extras out here are multiplied, extras in here are multiplied. All right. Okay, we're going to use this idea later. Now, if you'll look at this again, we're still going to use 108. So our factor tree is going to contain these teenagers still, so we don't have to do another factor tree, right? Okay, so I'm just going to write 2 times 2 times 3 times 3 times 3, okay? But the reason that this is different is because it's the cubed root now. Make sure everybody's here. Hi, Josh.
Hello.
This is the cubed root now. So this mother is still very understanding, but she's a little overprotective. And so she said, you can go out on Saturday night if there are 3 people in your group. You have to have 3 people in your group to get to go out. And you base that on the root, okay? So here are the teenagers, same ones as over there. And so the 3 say, woohoo, look at us. There are 3 of us in a group. We have a group of 3. We are a 3 group. Only 1 3 goes out because now they're a group. They were individuals in the house, but the only way is that they group up and 1 group goes out. Y'all see? Then the 2s look around. They say, we have a group of 2, but we don't have 3. So I guess we're staying home. Okay, so both 2s have to stay home in the house. Okay. Now, one of the hardest things to remember is when you put this all together and write the answer, you need to be sure to write the root. Okay, it's really easy to write this and get all this in there and then you forget the root. So be careful about that. 3, there's nothing to multiply out there, but in here, we're going to multiply. And so this would be the simplified answer for the cubed root of 108. That's a quick review of simplifying. I keep wanting to say reduce. Simplifying radicals. If you want more explanation, be sure and go back to the YouTube from Friday. We're going to use this idea today. Okay. Anybody else need this? Or Sherry, Josh, do you have any questions?
No.
Okay. I'm going to get rid of this and we're going to go to packet 2. Packet 2 starts, it has, if you put them in order, it has the divisibility rules on the front, and then it has a lot of radical operations. I'll show you the page that we're going to work with as soon as I get one pulled out. Okay, the divisibility rules, read over these, they're very helpful. And again, they're explained in the YouTube last week. Okay, one thing I want to explain about this, I still had a question this weekend. They're just giving you practice on making a factor tree, okay? Now, the one question that came up is, you know how I told you to circle the primes, but all the numbers are circled in here. What's going on? Well, this is just the way they showed you what they want you to fill in. They are not circling primes on this page. You see this? Okay, they are not circling primes. They're just putting circles where you're supposed to fill in an answer. So if you want to keep track of your primes, then get a highlighter or a colored pencil or something and circle your primes so that you can practice on that. But just understand on this page, everything's circled just because they want you to fill it in, okay? So don't be confused there. The same thing on the next page. There's just another page just like it. Okay, same thing. You're just practicing larger numbers here. And then again, actually, some more. Practice, practice. Then they didn't draw the little tree for you. They left you to draw your tree, still factor tree. You can see the importance of practicing these factor trees because of simplifying. The next one, lots of practice on factor trees. And then they want you to write the factors in prime form, just like we did. Now, okay, I want you to go, if you numbered your pages, I want you to go to page 10. The top says simplifying radicals, and number 1 has the cubed root of negative 24. And we're going to talk about this right now because this is something that I haven't explained, and it'll probably help. Okay, we're going to deal with negatives in radicals. Okay. Okay, we found out last week that the square root of a negative number is not possible in real numbers. It's not possible. Now, here's why. Okay, no real answer. Let's write this down with a little star or asterisk because you'll need to remember this. No real answer of a square root of a negative number, okay? No real answer. You cannot get a real answer. Now, when I talk about real answer, way back when we were talking about the type of numbers, I told you that all the numbers we're going to deal with are real numbers, but there is another category of numbers called imaginary numbers. Now, we're not going to have to deal with imaginary numbers here, but that's why I say no real answer, because there is an imaginary answer for this, but you don't have to worry about it. Okay? Now, the reason that you cannot get a real answer to the square root of a negative number is here. If I want to find the square root of 25, that means I need to find a number that is multiplied by itself twice, because it's square root, that's multiplied by itself 2 times to get 25. Well, most of us know that that is 5 times 5. And so the answer to the square root of 25 is 5, because that is the number that I can take times itself twice to get 25, okay? So now let's do this. I want to find the square root of a negative 25. Okay, now it has to be a number times itself 2 times because it's square root. Okay?
Be a 1.
No, it has, if you take 1 times 1, it's going to be 1.
Okay.
I need a number times itself that will give me negative 25. Okay, so if you take 5 times 5, what do you get? Positive 25, so that doesn't work.
Would it be negative 5?
Okay, if I have negative 5 times negative 5, Negative times a negative gives a positive. So that's not going to work. Anything else?
Negative
It
5
has to
times
be
5.
by, Josh, yes, what?
Negative 5 times 5.
That would work. That's the next one that people usually ask about. But the definition of square root means that these numbers have to match, and they don't. What I'm leading up to is that there is not a way that you can find a number times itself that will give you negative 25. Not going to happen. That's why you cannot find the square root of a negative. So remember this. If you have a square root, that's 2. If you have a square root of a negative, it's not going to happen. You don't have a real answer. Okay? Just, it's a memorized thing. I've shown you why, but it's a memorized thing. Now,
Is it
taking,
only the negative 2?
I'm
Or
sorry?
maybe like a, never mind,
It's okay. What?
it's okay.
All right. Now, we're going to take a side trip real quick because negatives are so confusing. But what if I had negative square root of 25? What about that? What you need to do is use the radical the same as parentheses in our PEMDAS, okay? Which says do the parentheses first, okay? So I'm going to do this imaginary because the radical is the same as parentheses, okay? So I'm going to do this first. Can you find the square root of 25? Say yes, okay? And that is 5. And then after that, in PEMDAS, it says exponents and then multiply. Now we can multiply. This negative out front is the same as negative 1 times, okay? So we have negative 1 times 5. So the answer to this is negative 5. Because I found the square root first, then multiplied. The difference is this won't work because it's on the inside. Outside will work. Y'all see? Okay, now that's square roots. I want to talk to you about cubed roots because negatives are okay in cubed roots. Cubed root. Now this means I need a number that will be times itself, times itself, times itself 3 times to give me negative 8, okay? There's a negative under the radical, but now we're talking about a cubed root, okay? So in this case, the answer to this is negative 2 because you can take negative 2 times negative 2 times negative 2 and get a negative 8. See, it's a number times itself. This negative times negative gives us a positive. Negative times negative gives us a positive. Times a negative gives us a negative. So if you have a cubed root, the negative is okay. All right? Now, let me see. So, okay, there's a bunch of stuff I want to tell you. I'm putting it in order. So if you have a number and you're supposed to find a factor tree, I had this question this weekend. If you're doing a factor tree for negative 8, then you're going to say 4, we're going to ignore the negative for a minute, 4 times 2, and then we're going to say 2 times 2, okay? This mother wants groups of 3, right? shoot. This mother wants groups of 3 before they can go out. Here's a group of 3. So a 2 group can go out. There's nobody that has to stay home. If you don't have anybody that needs to stay home, this. And then the last part is, if you have a cubed root of a negative, your answer is always going to be a negative. You just put this negative on after. If it's cubed root, understand, if it's square root, If it's cubed root, yes. Okay, now the last thing that I want to tell you about this before we go on to some of the problems, I want you to see that, yes, there is no real answer to the square root of a negative number, but there's no answer to a negative number for a square root, a 4th root, a 6th root, an 8th root, if there are even roots. Even roots of a negative number, the same is true. All even roots. So if it's the 4th root of a negative number, don't even try a factor tree because you can't get a real answer. Okay? The same is true over here. The same is true for a 3rd root, a 5th root, a 7th root, a 9th root, an 11th root. If you have odd roots, the answer is negative. Odd roots of a negative number. Negative. Okay, odd roots of a negative number, the answer is negative. And to clarify, if I have the cubed root of 27, that's not a negative number, so the answer is not negative. You see, I'm just talking about odd roots of a negative number. Yes? Okay, these are some rules that it's going to take a little working with to remember, but keep referring back to this. We cannot find a real answer to an even root of a negative number. Not going to happen. Just if you see it, mark it out. There's no answer. Okay, for now. There's an imaginary answer. Okay, and odd roots of a negative number, you can find by doing the factor tree. The answer will always be negative. Does it help? All right. Refer back to this often. Questions, Sherry, Josh?
No, I'm good.
Okay. Sherry?
No, ma'am, I'm good.
Okay, I thought you passed out.
No, not yet.
Not yet. Okay, let's actually go to the worksheet. Let's try to take you through some of the pages. We're still going to add and subtract radicals today, so I'm going to try to move on through here. So this page that I just told you about, simplifying radicals, and the first one was the cubed root of a negative 24. That one can be done. That one can be done. Don't use your calculators. I want you to know how to do this. Okay, and the next page is same thing, larger numbers. Okay, I want you to go to page, it will be 12. It says adding and subtracting radical expressions. Adding and subtracting radical expressions. If you numbered it, it's page 10.
Simplifying radicals.
No, adding and subtracting. Brandy, if you found it, will you let Rachel look at that? So, okay, and you found it. All right. Now, when we're adding and subtracting, we're going to use the same idea. We're going to use the same idea of combining like terms that we did a long time ago. We said, did you find it? We said that if you have like terms, these are all X's, then you can combine those, right? You can put them in one big pile. So you have 5 X's minus 3 X's is just 2 X's, right? But it cannot be combined with Y's. So the Y has to be added separate. Now, do you guys agree with this? You know, we're adding common terms, right? Okay, then number 1 is written with radicals, and we are going to use the same rules. So we're going to say 5 square roots of 3 minus 3 square roots of 3 plus 4 square roots of 8. In this case, square roots of 3 and square roots of 3 are common terms. You see? So I can put those together. I can say I have 5 of these, and I'm going to take away 3 of these. So now I have 2 of these. You see, I don't do anything with the radicals because I'm adding and subtracting. So I'm just adding normal things, okay, common things together. Over here, square root of 8 isn't the same as this. So I have to add it separately in this problem. It's this simple. You just put common terms together. Ask your question.
Is that 2/4?
2/4? No. No, this is radical operations are different. Okay. So I've got 2 of these. I was just trying to simplify this where it looks simpler and prettier. And I just put all my square roots of 3's together. But this doesn't belong in the group, and so he has to be written by himself. Y'all see? Okay, this is the same idea. So if you look at, okay, number 2 is going to bring up something else. Okay, number 2, and this is going to be the crux of what we're going to do today. Number 2 will introduce you to it.
Miss Deborah, so we were done with that one?
Yes, actually, there's no equals, and so there's not an answer to find. The instructions simply say, simplify. And that means make this as efficient and short and pretty as possible. But since there's no equal sign, there's no answer.
Okay.
Okay, so yes, that was the end. Okay, we're just simplifying. Let's look at number 2. Okay, as you look through here so far, we have common terms. We have square root of 7 here, square root of 7 here. How many of them are here? 1, good. Remember the invisible guy. So when we put these together, I have a positive 1 plus a positive 2. So I have 3 square roots of 7. But the square root of 28 is not the same. And so I'm going to write this by itself. Now, this is the next step that I want you to understand. If you look at a problem like this, and you find a radical expression that the number inside is bigger than a prime, then I want you to see if it will simplify by using your prime factor tree. So this is a prime number. I know that's as far as it's going, but let's just look at this. We have 7 times 4 is 28. 7 is a prime. 2 times 2. Now we're leaving this alone a minute and just talking about this one right here. So here are our teenagers, and it takes a group of 2 to go out of the house. So let's see what happens. Now, before you take anybody out of the house, I want you to understand that if there is a number already out there, this adds into the equation. So 11 is already outside of the house. 11 is already there and has to be there. So now when we look at the teenagers, we say, here's a group of 2. So a 2 group comes out, and the 7 is left at home. So now I'm going to come over here because I keep running out of room. So now instead of 11 square roots of 28, I have simplified that to 22 square roots of 7, right? So I'm going to write that in its place. 22 square roots of 7 plus 3 square roots of 7. Now you can see that because I simplified this, now I have common terms. Okay, so now I can add these together. So I have 22 of these plus 3 of these makes 25 of these. Y'all see? Okay, so there are 2 new things that you found out here. One of the new things is if something already has a number out front times the radical, it must be included in the simplification. And the second thing you found out is we don't have to leave it like this. If this in here is not a prime number, you should always test and see if it can be simplified. Y'all see?
How did you get the 25 again?
When this came down to 22 square roots of 7, I put that right here in place of this and finished the expression. Now I have common terms here. So 22 of these plus 3. 22 plus 3 is 25. Does that make more sense? Need another one?
Is that a mic? Oh, no, sorry. Okay, no, that's fine. 22 plus 3. Okay.
Yes, always ask about my writing. Sometimes like I write all over the place and it could be very confusing. Be sure and ask. How about y'all at home?
I'm good.
I got it.
So far, so good, okay?
Yeah.
We're not going to multiply and divide radicals today, but I do want to do a couple more of these and see if we run into anything that you guys are going to have a question about. But this is as far as I'm going to go today. Okay, let's go to number 4. 4 looks pretty scary, right? Okay, let's look at number 4. It looks scary, however, we're okay. Because we're not scared. Minus 2 square root of 44 minus 5 square roots of 10. Okay, yeah, it could look a little scary. So okay, I keep checking so I don't forget people wanting to come in. All right, as we look through here, we see so far we do not have any common terms. However, we do have some numbers that are larger than a prime, the 44 and the 10. So we know before we get a final answer, we need to try the factor tree. Okay, this one, 11 is prime. So this one's done. Okay, we'll bring it down in a little bit. But right now we're going to see if this can be simplified at all. So now I have 2 times 22. You can start this any way that you want to. 22 will reduce to 2 times 11. And 11 is prime. And so down here, I already had a 2 out front. Here's the house. I need 2 people in a group. So here's a 2 group that goes out front. The only thing left is an 11. So now I have 4 square roots of 11 for that one. Is everybody following there? Okay, and then let's look at this one because this one is not a prime either. So I'm going to break this down to 5 times 2. And when I come down here, there's already a 5 out front of the house. Here's the house. Okay, this mama wants groups of 2. There's no groups of 2. So the 5 and the 2 both have to stay home. Y'all understand that one? And so I actually down here, I have 5 square roots of 10. And then over here, we said this was prime. So we could change it. And there's a minus sign. And there's a minus sign. So our problem with all of our work looks like this now. Are y'all with me? So the only 2 common terms I have are here and here. That one's not the same. Everything's simplified, so here it is. There's a -3 minus 4. That means we have 2 negatives. That doesn't mean it makes a positive. We're adding. So when you have a stack of negatives, you have 3 of them here and 4 of them here. We're stacking them, okay? And we just have a bunch of negatives. So I have a -7 square roots of 11 because I put my common terms together. And then minus 5 square roots of 10 because they are not common, they have to be written separately. Is this making more sense?
Yep.
I see nodding heads. I see wide-eyed, oh my gosh looks. And I see, looks. I can't see you guys online.
Yeah, it makes sense to me.
Sorry, Josh.
So yeah, it makes sense to me.
Okay. It's going to make more sense when you have to do it yourself, but I am open to doing another one. Let's also look on the next page. See, I think it's the same thing. So this is page did I say 10? This is page 12 and 13 and 14. They're all practicing doing the same thing. Ooh, 15. There's 4 pages of this adding and subtracting radical operations. The last page we will talk about tomorrow, fractional exponents, okay? Look through here. Look through those next 4 pages, see if you have anything that you would like for me to work. And remember, here's one that might try to fool you, but you guys are smart now, so probably not. Let me call your attention to it. If you see something that says 3 square roots of 8 minus 16 cubed roots of 8, understand, y'all, cannot combine square roots with cubed roots. I don't care how much they simplify. You can't combine square roots with cubed roots. They're always going to be separate, always, when you combine this, okay? So don't let that throw you. Even though these they'll break down, that's fine. They will simplify. Don't try to add square roots to cubed roots. Never, ever. Okay.
It says to.
Do what?
The one that says to.
Well, then they're wrong, and you just tell them, poo, not going to do it. Be a rebel. Do you see any more on there, or do you want to give it a shot and then ask me as you're working?
I see one on page 15.
15?
Number 4.
15, number 4. Page 15 is this one for you all, and she's wanting number 4. I'll put it up on the board. Okay. This is the one up here. It says sheet 1. It's still adding and subtracting. Number 4. Okay. This is number 4 on page 15. As we look at it, the one quick look, we look at it, they're all square roots, so we're fine there, right? Okay. And none of these are primes, are they? So we should try to simplify every one of them. So I'm going to start here. 4 times 2, 2 times 2. So when I figure out who gets to go outside, 35 is already there. Don't forget this. Very, very important. And now I'm going to look at the teenagers. Mom said groups of 2. So this 2 group gets to go out, but this 2 has to stay home. And so I have 70 square roots of 2 from this one. And then 18 is 2 times 9, 3 times 3. So when I decide on the house, who gets to go out, 8 is already there, and hollering, you guys come on. Okay. So here's a group of 2, left over 2. And then we come to this one. 19 is already out here. We have a 3 comes out. And 2 2 has to stay home. That's kind of 19. There we are. And so this one becomes 24 square root of 2, and this one becomes
57.
square root of 2. Common terms, huh? Let's get the signs in here. And now, we have 70 of these minus 24 of these, which would be 46. 46 of these right now. 46 of them minus 57, probably negative. Please check me. Negative 11 square roots of 2. I can put them all together because they're all square roots and they're all square roots of 2. So they're common terms. I can put all of them together. Rachel?
So you're
Right.
minusing
I'm
70,
seeing it,
24,
right?
and the 57?
Yes, in your calculator, you can do 70 minus 24 minus 57 and get one answer. So that's what Rachel is checking me because sometimes when I do it fast, I do it real wonky.
No, you got it correct.
I did?
Yeah.
Okay. Negative 11 square roots of 2 because I looked, first of all square roots, no cube roots, so there's not a problem there. Common terms, well, these are, I guess, but none of them are primes. So you should try all of them. I've got some interference here. There we go. You should try all of the radicals, the radical expressions right here that are not primes. You should always try them. Sometimes they will simplify, sometimes they won't. But look how nice it came out when you simplified. Pretty nice, huh? Do you get
Mhm.
the idea?
Maybe a little bit.
Yeah, it'll take some practice. It's a new thing again. Tomorrow we're going to deal with fractional exponents like x to the 1/2.
No.
Yes. And then after that, probably this week, we're going to multiply radical expressions. Multiply them. Right now we're adding and subtracting, so we're putting common ones together. How do you feel? Overload? Overload. Okay. Well, I am here for you. And remember, Josh and Sherry and whoever else comes online, remember, I can leave the Zoom open. I will probably stop the recording, but I will leave the Zoom open for any questions from the remote people. All righty?
Okay.
Oh, thank you. I was very thankful for it this morning. What do you think, Josh?
Oh, it's all good.